Did somebody say small modular molten fuel salt thorium fuel cycle thermospectrum breeder reactors? Well, I just did after a lot of practice, and hopefully by the end of today's exploration, you will know what the heck that means and why it might be important for the future of humanity, free humanity. But if you need something to set the table for today's episode, feast your eyes on this.
China is planning to build a nuclear power plant on the edge of the Gobi Desert that would be the first in the world to use molten salt as the fuel carrier and coolant. It would also be the first to use the radioactive metallic element thorium as a fuel source instead of the uranium traditionally used in nuclear reactors.
In April 2025, the Shanghai Institute of Applied Physics began operations for the refueling of the experimental thorium reactor TMSR LF1. And this news caused a significant stir among nuclear energy professionals and enthusiasts.
Traditional nuclear reactors run on uranium, specifically uranium-235, which makes up less than 1% of all uranium on Earth. Finding enough uranium-235 to power the world's reactors is like searching for diamonds in a beach full of regular sand. Thorium is the opposite. There's so much thorium on Earth that we literally don't know what to do with it all. Mining companies currently treat thorium as waste because there's been nowhere to use it. China alone has enough thorium reserves to power their entire country for 20,000 years. 20,000 years. That's longer than human civilization has existed. But here's the crazy part. Thorium can't actually power a reactor by itself. It's like having a pile of wet wood that won't burn no matter how many matches you throw at it. You need to transform it first. And that transformation happens inside the reactor while it's running. The reactor literally creates its own fuel as it operates. Chinese engineers discovered how to make this process so efficient that their reactor produces more fuel than it consumes. It's a nuclear reactor that grows more powerful over time, like a campfire that gets bigger every time you add a log. The breakthrough isn't just the thorium. It's the revolutionary way China designed the entire system. Traditional nuclear reactors are basically giant pressure cookers filled with solid fuel rods and water. The water gets so hot it turns to steam, but it's all trapped under enormous pressure. If something goes wrong, that pressure can explode outward with devastating force. China threw out that entire design and started from scratch. Their reactor uses molten salt instead of water, liquid salt heated to over 1,300 degrees Fahrenheit. The thorium fuel dissolves directly into this molten salt, creating a thick, glowing liquid that flows through the reactor like lava. Here's the brilliant part. If the reactor overheats, the molten salt expands and actually slows down the nuclear reaction automatically. It's like a car that automatically slows down when the engine gets too hot. And if there's ever a serious problem, they simply drain the molten salt into underground tanks where it cools and solidifies harmlessly. No meltdown, no explosion, no radiation release. The laws of physics literally make it impossible for this reactor to have a Chernobyl or Fukushima-style disaster. But the most incredible breakthrough is how they solved the refueling challenge. Traditional reactors have to shut down because their fuel is locked inside solid metal rods. Removing these rods and installing new ones is like performing surgery on a patient. You can't do it while the heart is still beating. China's liquid fuel system changes everything. Since the thorium dissolves directly into the molten salt, they can add new thorium and remove waste products while the reactor keeps running at full power. It's like being able to change your car's oil while driving on the freeway. The Chinese team developed a continuous processing system that works like an incredibly sophisticated coffee filter. Fresh thorium flows in, waste products get filtered out, and the reactor never misses a beat. This single innovation eliminates weeks of downtime and makes their reactors dramatically more efficient than anything else on Earth.
Awooga, alert, underlay. I don't know. I hope that got your attention, and I hope you're properly frightened. And if so, I have some news for you. It gets even worse. And we can take this from Defense News, that bastion of truth. China unveils the world's first thorium-powered cargo ship, carrying up to 14,000 shipping containers, talking about how China has unveiled the world's first thorium-powered cargo vessel, marking a significant milestone in nuclear maritime engineering and energy innovation. According to the South China Morning Post, the newly developed vessel is powered by a 200-megawatt thorium molten salt reactor and is capable of carrying up to 14,000 standard shipping containers, making it one of the largest and most advanced nuclear-powered cargo ships ever built. And you can continue reading on about the specifications of this ship that has yet to be built and what it portends for the future of global shipping and, of course, China's domination of future global supply lines. But I think you get the idea. We are on the cusp of some very interesting breakthrough developments in nuclear engineering specifically and in the energy sector generally. And while this might be a good thing for humanity, it is certainly immediately going to be put into the two-dimensional chessboard as part of the calculations of whatever future conflicts we are being steered into. So if you don't know about how the two-dimensional chessboard does not represent the three-dimensional reality that we are living in, and if you do not know about the multi-pillar world order in which the US Anglosphere is just the central pillar in an entire system that is supporting up a technocratic vision of control of humanity that's coming into view, well, boy, do I have some catching up for you to do. You can take a look at my recently released episode 492 of the Corbett Report podcast on what's Greenland really about to find out more about that and how, yes, China is starting to move ahead in thorium reactors. Oh my God, they're going to win the race. Might not be the best way of understanding what's really happening here, but that is the way that the mainstream and establishment media is going to try to portray these technological developments within the context of that fake, phony, engineered, two-dimensional nation-state system in which it's our nation-state versus their nation. So I sure hope Uncle Sam and his allies can come along and start using and taking advantage of these thorium molten salt reactors so that we can power the AI data centers that will give us the upper hand in this 2D chessboard conflict. I think you know how that story goes. But I hope we don't lose sight of the bigger picture here, which is that throughout the entirety of human civilization, at least, civilization has always depended on energy. And tyrants of all stripes throughout all of recorded human history have always understood that weaponizing, monopolizing, and trying to take a greater share of energy has always been the determinative factor in who is really in charge of state shaping and steering a civilization. Thousands of years ago, the tyrants, of course, would rely on raw human power, slave labor, to get things done. And within the past 150 years, humanity has unlocked the wonders of the industrial era machine age, in which oil, of course, was the basis for industrial production and production generally. And that is exactly why, as of course you will know from having watched How and Why Big Oil Conquered the World, of course, the big oligarchs of the 19th, 20th century were oligarchs, as well as financial oligarchs, of course. But those things play into each other because cornering the energy market has always been incredibly important for steering civilization. The Rockefellers certainly knew that, and I think other oligarchs have learned that lesson. But now we are on the cusp of something that could be potentially very different. And of course, we have heard about this potential for a very long time. We could cast our minds back to the Atoms for Peace propaganda that was being foisted on the world by the Eisenhower administration back in the 50s, and energy too cheap to meter. But I think, hopefully, clued in and switched on Corbett reporters in the crowd will know by now how that potential revolution in energy was, of course, immediately steered into just another way of further ensconcing control and centralization of power, namely by taking what could have been an interesting technological development, a molten salt nuclear reactor, and changing the design around and making it so, well, you know what, we actually want these uranium fuel cycle nuclear plants in order to breed more weapons fissile material. And that is the direction that the US took after some initial toying around with the idea of thorium molten salt reactors. No, we're going to go with the uranium ones. And again, I can throw in some links in the show notes for today's episode if you need to get caught up to speed on that. But here we are at a crossroads, a fork in the road of civilization. And down one path, yes, of course, the the tyrants and the would-be oligarchs of this two-dimensional chessboard are, of course, going to be attempting to maneuver their position of control over these technologies as they emerge so that they can harness this energy to fuel their AI data center monstrosities to further solidify their control of the panopticon state, etc. On the other side, there is the potential, however small it may be at this moment, but there is the potential. Well, what if this energy could be harnessed for free humanity, for free and independent communities to get themselves off of the networks of control, the grid, both literal, but also the metaphorical grid of control of the oil industry and everything that comes with it? What if humanity could free itself from those shackles and achieve energy independence? Is that even feasible, let alone possible? So what if instead of the idea of using these thorium molten salt reactors to create these 1 gigawatt gigantic nuclear power plants that are going to be running the AI data centers and the industrial machinery to create the military industrial weapons of mass destruction, what if we had small modular nuclear reactors that were, I don't know, 40 megawatts and capable of powering a small community that could be assembled in a factory in a single day and shipped in a single shipping container, where it could then be tied into an existing boiler and electric power generation infrastructure. What on earth could that possibly be? And further to my conversation last October on Solutions Watch with John Kutch of the Thorium Energy Alliance on the thorium solution, what if instead of light water uranium fuel reactors or other meltdown-prone nuclear configurations, what if it relied on thorium-fueled molten salt reactor with a built-in passive safety system that means meltdown is essentially impossible? What could we even imagine that? Well, there are people who are not only imagining that, but attempting to perhaps bring us toward that reality. Companies like Copenhagen Atomics, obviously based in Copenhagen in Denmark, they are currently working on mass manufacturing small modular thorium fuel reactors. So what on earth is this about? Well, you can, of course, go to CopenhagenAtomics.com to find out more about their plans and building and testing and proving and what they're working on and why and how. Or you can go straight to the About Us page for the sort of the basic breakdown. Copenhagen Atomics was founded in 2014 with a technical by people with a technical background in relation to Technical University of Denmark. Right from day one, the goal was to make thorium energy at a lower cost than any other energy source and enable fast deployment of this new reactor design. And they talk about how Copenhagen Atomics presents a new reactor design with different physics than all other previous reactor designs, resulting in much lower energy price and less materials used. So this is their vision. And again, there's a lot more technical detail here for those who are interested in diving into it on their page. But I decided, why not talk directly to the man himself? So I asked the co-founder of Copenhagen Atomics, Thomas Jan Pedersen, about Copenhagen Atomics, their onion core nuclear reactor design, and how it differs from previous light water reactor and other solid fuel reactor designs.
So all the other nuclear reactors we have in the world are called solid fuel reactors. That's sort of a broad term showing how all of those reactors work. And it basically means that all those reactors have fuel rods inside of them. And those fuel rods are typically made from uranium. That's the most common case. And there's all kinds of different configuration of these fuel rods and the sort of the chemical composition of the uranium and so on. And that's the different, but they kind of all work the same. And then molten salt reactors is a very different reactor concept. It's where you make a liquid from salt. So it says essentially, if you take table salt on your kitchen table and melt it, it would become a liquid. It looks very much like water, but of course it melts at high temperatures. So for table salt, it melts at 805 degrees Celsius. But for the molten salts we use in molten salt reactors, they melt at around 500 degrees Celsius. And those molten salts can hold uranium or thorium inside of them, a little bit like salt and salt water. But it's still a transparent liquid, and you can pump it around with pumps. And when you do that, you can make a special configuration called a molten salt reactor that can generate energy. And this has been known since the 1950s. And it was actually this guy, Alvin Weinberg, who came up with that idea. And they built a reactor back then, a number of them, but they had especially one that worked quite well. And now lately, in the last sort of 5 years, the Chinese have built one as well that they have in the Gobi Desert that is also running. It's a test reactor or experimental reactor, but it is working, and they are generating energy from that one.
All right, I've been watching various promotional material on your YouTube channel and other people exploring Copenhagen Atomics and what you're doing, so trying to get my head around this. And from what I understand, you have developed some sort of onion core breeder reactor. Tell us a little bit about that configuration, why it is so interesting and potentially world-changing.
Yes, so the world-changing thing, at least for us, is that the classical reactors, all those solid fuel reactors, and sometimes we know them as light water reactors, they only consume sort of less than 1% of the uranium that you dig out of the ground. So when you do all the mining and you do enrichment and so on, you do the fuel fabrication, you end up using only 1% of that. So of course that generates a lot of extra work in the mining and the transporting and the enrichment and all the chemical processes, and that makes it expensive. And also afterwards you end up with what some people call nuclear waste, other people call it spent nuclear fuel, but regardless, you end up with a material that the light water reactor cannot use and get more energy out of it. So we need other types of reactors to get the last 99% of the energy out of that. And we discovered that these molten salt reactors combined with thorium is actually very, very efficient, both at generating energy from uranium that you mine from the ground, but also very efficient at generating energy from the spent fuel from classical reactors. So essentially, you can get 10 times more energy out of the spent fuel from light water reactors in our type of reactor. So, that's great. That some people call it waste, and there's a lot of debate about where do we put it? Can we put it in Yucca Mountain, or in Finland they are putting it very, very deep underground, and other countries are debating how to handle it. But it can actually be sold to companies like ourselves, and we can reuse it and generate 10 times more energy than the first reactor. And we've already done all the mining and all the transporting and all of that. So I think that's at least a good idea. And of course, it's our reactors are a little bit more technically advanced than the light water reactors, but we've developed all these technologies for many decades. So I think the world is about ready to do this now. And the onion core is something that we came up with, which is sort of a configuration where these molten salt reactors are even more efficient at generating energy at low cost. So it's all about making the reactor unit or the reactor core smaller. And also there's something called neutron economy. It's how you use your neutrons inside the reactor efficiently. And that eventually brings you to a low price. If you have a really, really, really good neutron economy in your machine, you get a low price of energy. And that's what we have been able to do. We've been able to make that reactor core quite small. So it depends a little bit on the configuration, but it's between 2 and 2.5 meters in diameter. So it's much smaller than almost all other reactors in the world. And like I said, it can generate energy at lower cost than the other reactors, and it can burn roughly 95% of the materials that we mine out of the ground. So it doesn't create a lot of waste.
So we're talking about a reactor core that's 2.5 meters in diameter. Is that right?
Yes.
And all right. So tell us, give us a sense of how much energy that we could get out of that.
Yeah. So the explanation for kids is that one of these reactor units with one reactor core can generate the same as 60,000 horsepower. So that's roughly the same as a marine engine in one of the very big ships, container ships, or it's the same as one of the really big engines on a airplane, like the big jet engines on some of the biggest planes. So that's roughly the amount of energy each one of them can generate. And then you can, of course, put many of them next to each other if you want a really, really big power plant to generate electricity for the grid or for a data center or something like that.
And if we were to measure in megawatts rather than horsepower?
Yes. So the thermal output, so the temperature output is equal to 100 megawatts of thermal energy per unit. and that translates into roughly 42 megawatts of electricity per unit. And if you need a 1 gigawatt power plant, which is similar to many other nuclear power plants we have today, then you would need 25 units next to each other.
And when you talk about units, so for people, my wonderful video editor, Brock West, will put this up on screen so people can see this configuration. But you have a configuration where you have, of course, the reactor core, but it's contained within a unit that would be able to fit inside of a shipping container. How does this work?
Yeah, so that's also what we wanted to do when we started the company. We wanted to figure out a way to make these thorium molten salt reactors in a size where they could easily be mass manufactured and easily transported on the road to whatever site they need to go to and generate energy. And of course, all the other products we make in the world are typically transported as shipping containers or something of that size, because it fits well into our transportation system. So that's sort of roughly the explanation of the configuration. So it is, 30 meters long. It is a sort of almost the size of a building or a house. So even though the unit itself that we manufacture in a factory is small, like a 40-foot shipping container, when it's at the power plant, the size of the power plant is similar to other power plants.
All right, I'm going to steal my next question from the internet, because I noticed on a video profile that was posted a few months ago by Engineering with Rosie, can Copenhagen Atomics make thorium reactors work? There was an intriguing comment made by one of the commenters that I thought, well, hey, I can put that directly to Thomas myself. So this commenter writes, I have seen a fair amount about the mechanical side, but almost nothing about how they expect to clean the salt/fuel mixture and transport the fuel generated in the mantle to the salt/fuel mixture. Since that is such an important part of keeping these units running, I would be interested to hear how they expect to do that.
Yes, certainly. So it is true that the fuel fabrication process is completely different from these solid fuel reactors. And the reason why we started the company is partly because one of our founders, his name is actually also Thomas, Thomas Steenberg. He did his PhD working with molten salts even before we started the company. So when I met him, he already had a lot of knowledge about how to handle molten salts. And some of the things he has worked on, and the group where he did his PhD worked on at the university, was removing impurities from the salt. And that's essentially how we got started. And that's also how you remove those fission products, which is what makes molten salt reactors better than solid fuel reactors. It's the fact that the fuel is liquid and you can actually remove the fission products or the exhaust products from the reactor while it's operating. And that gives you a much better fuel economy. And that is essentially why we can make it smaller and lower price and so on. And the other thing that is very important about molten salt reactors compared to the traditional solid fuel reactors is that molten salt reactors run at atmospheric pressure. So it makes it cheaper to build, but also it makes it much less likely that there could be sort of a pressure accident where you lose the pressure. And essentially losing the pressure in a light water reactor leads to a meltdown, which is what some of the reactors did in the past.
Well, let's turn to the whys. Why are you motivated on this subject? What is important about this? Why does Copenhagen Atomics want to revolutionize the nuclear industry?
Yeah, so we actually doesn't care if it's the nuclear industry or the other. It's energy in general. I mean, we think that energy is the most important component in generating a prosperous society. It's super important. And we can actually see that if we go back and look at different countries, then if they install a lot of energy capacity, then 15, 20 years later, their GDP starts to go up quite rapidly. And we've seen that very clearly with China or Korea, back when Korea after the Korean War. We've seen it in Eastern Europe. I mean, we've seen it again and again in many different places, that when you add a lot of additional energy to a society, then the prosperity goes up and the GDP goes up and everything some decades later. And we believe that, everybody in the whole world should have access to more energy because it creates a better life. And I think even people that are in very rich parts of the world, they also want more energy.
Once again, that is Thomas Jan Pedersen of Copenhagen Atomics at copenhagenatomics.com, where you can go to find out more about the onion core reactor that they are developing, that they are set to test in early 2028. You can find out about those plans, how it's developing, what kind of tests have been done already, what they envision for the future, etc. Not only at Copenhagen Atomics and not only on their YouTube channel, but on many other channels out there that have talked about this and talked to Thomas about these technologies that are starting to come into view and are very soon set to transform the energy landscape. If you want more information about this concept in general, you could turn to thoriumsmr.com, which is a handy-dandy explainer about thorium small modular reactors, the future of nuclear energy. And they explain all of the different facets of this, including the thorium fuel cycle and primary and secondary coolant systems, heat exchanger and power generation, containment and shielding, etc., etc. Passive safety features, all of the things that make thorium small modular reactors, thorium-fueled small modular reactors, so interesting and potentially game-changing. And if you want more and more on that, you could turn, for example, to an article like this one from The Conversation up a couple of years ago, or last year, I should say. Nuclear in your backyard? ? Tiny reactors could one day power towns and campuses. Talking about the microreactors, not even the small modular reactors that are being worked on by Copenhagen Atomics and others, but microreactors under 20 megawatts that could be shipped on a truck, but powerful enough to supply an entire town with its energy needs. And again, you can find out more about the history of microreactors and how and when and why and in what form they may or may not be coming to a community near you, maybe even your own agoristic community, your own sovereign community of like-minded people that we all know you're already building, right? Because you've seen, for example, my work on Solutions Watch on building communities. So maybe you need a micro reactor to power your community, or maybe it will be used in other ways. And for that, you could, of course, turn to the U.S. Department of Energy, which has a article up from last year, 3 microreactor experiments to watch starting in 2026. Because yes, you better believe the Department of Energy is very interested in this technology and how it may or may not be used. And they're tracking things like the E. Vinci microreactor from our good friends at Westinghouse, and the Kaleidos microreactor from something called Radiant, R1 microreactor from Antares. Yeah, you better believe that, of course, this technology is going to be commercialized by the usual corporate oligarchs and is going to be stewarded and shepherded into existence by the U.S. Department of Energy and the other shiny badge-wearing officers of the law that are going to create all of the restrictions to make it difficult, if not impossible, for small communities to do this on their own. Maybe. And of course, this will also play into that 2D chessboard politics game. U.S. conducts first air transport of nuclear microreactor in bid to show technology's viability. Yes, the U.S. Department of Energy and Defense on Sunday, for the first time, transported a small nuclear reactor on a cargo plane from California to Utah to demonstrate the potential to quickly deploy nuclear power for military and civilian use. So, yes, of course, the oligarchs are going to try to use this for their usual oligarchical purposes. Case in point, this article up from just a few months ago, Bill Gates strikes major partnership to build next-gen nuclear reactor, a global nuclear supply, talking about how Bill Gates is helping to advance a growing source of nuclear energy with an overseas energy developer. And long story short, this vice chairman of South Korean shipbuilding giant HD Hyundai is discussing coordinating the development of small modular reactor projects as part of its partnership with Gates's nuclear energy startup company, TerraPower. Yes, as I have mentioned many times in the past few months, since Gates has had his remarkable turnaround on climate, and oh, you know what? It isn't the human-ending existential threat I've been telling you it is for the past couple of decades. But you don't have to worry about that. We need human flourishing, and of course, it just so happens, coincidentally, that Gates is invested in TerraPower and other nuclear companies that are working on supplying the energy for the AI data center beasts that are coming online. Yay. Of course, they are trying to weaponize, financialize, and monopolize this technology for themselves. But to put the argument in a form that I think most Americans would understand, saying, I can't use this technology because they use it, is as stupid as saying we shouldn't have weapons because they have weapons, which seems to me to be self-defeating. So the point is, can this technology be wielded by and for free, independent, sovereign human beings for their own purposes? Well, I'm sure if the US Department of Energy and others have their regulatory say over this technology, the answer will be no, which is why perhaps the answer to true freedom won't be found in heavily regulated places like the United States of America. But having said that, there are many, many considerations in all of this, including the consideration that this is all hype and it's all overblown and there's nothing really there, or at least not as much as some people are claiming. And if you want more on that, I will throw in a link to a channel that seems to be quite popular, False Nuclear, where this nuclear energy expert likes to debunk various videos hyping up various nuclear announcements. So I will throw in a link to his video reacting to the inconvenient truth about small modular reactors. And you can see more about his take on these types of considerations and whether or not we're really on the cusp of the type of revolution that some people are claiming that we are. But having said all of that, of course, I am no expert on these matters. I am simply a concerned person who is interested and capable of looking into these things, exactly as you are, which is exactly why I'm calling on Corbett Report members in the audience who have knowledge on these matters. Please, I would like to hear your 2 cents. First of all, do you think that, for example, thorium-fueled small modular reactors are a viable option for powering independent communities of the future? And if not, what is the answer to this? Where will the energy for powering independent sovereign communities come from, if not from the grid that is operated and controlled and monopolized by they, them, those? That's the question on the table for today because, yes, here in Solutions Watch, we are examining the possibility of escaping energy poverty. So let's leave it there for right now. If Corbett Report members are interested in joining this conversation, please log into corbettreport.com and leave your comments in the comment section of this post. Thank you again for joining me for today's exploration. I am James Corbett of corbettreport.com. Looking forward to talking to you again in the near future. Computer whiz kid.
Part of your genius is that you are a computer whiz.
Cutthroat businessman.
The US Justice Department contended that the software giant had breached antitrust laws.
Selfless philanthropist.
Bill, even your harshest critic would have to admit that your philanthropy work is, planet-shaking, incredible.
Ruthless eugenicist.
But that's called the death panel, and you're not supposed to have that discussion.
As more and more of our world is coming to rely on Bill Gates for his guidance.
One of the best informed voices is that of businessman and philanthropist Bill Gates.
It is time to ask what really lies behind Gates' quest for control.
Things won't go back to truly normal until we have a vaccine that we've gotten out to basically the entire world.
It is time to ask, who is Bill Gates? Watch the complete documentary for free at corbettreport.com/Gates, or support the work and purchase a DVD copy at newworldnextweek.com.